In this video, we're going to look at a nice funky example of incorporating general solutions and identities together. And so we've been given 2 cos x equals 3 tan x, and we've got to show that the equation can be written like this. And so for starters, you just want to pick up on the easiest mark that's waiting for you, and that's the fact that tan is sine over cos. Be careful, if it's 3 tan, it doesn't become 3 sine over 3 cos, it's just 3 sine over cos. The next thing that's buzzing in my mind is that I've got fractions all of a sudden. And so when I've got fractions, I want to be looking for the LCD, which is, in this case, just the term at the bottom. And so this needs to be times by cos. So it will become cos squared equals 3 sine x, and I'm just going to take it all to one side. So it ends up looking like that. I can see that I'm heading to a place that only has sines, so that's one indication. The other indication is that I've got a squared, and when I see squareds, my mind buzzes straight away with cos squared is 1 minus sine squared. And so it's going to be, instead of cos squared, it's going to be 1 minus sine squared x, carefully in brackets. And once I've done that, it should just be chilled. And so I'm timesing it in carefully, and they want the answer to be positive 2 sine squared x. So I'm basically taking it to the other side, or if you want, you divide everything by a negative. So if I divided everything by a negative, I'd get 2 sine squared x plus 3 sine x minus 2. It's always good to make it look like the question. Makes examiners happy. Then determine the general solution of this. And so the general solution, for starters, I would want to just see this as a trinomial that I can factorize. And so it will just be 2 sine x and a sine x. The signs, because it ends in negative, will be different. So this would be plus 2 and minus 1. If you want to test, you can times this out and times this out, and you should get back to positive 3. And then what's the answer that comes out of this bracket? It will just be a half. Or what's the answer that comes out of this bracket? It will be minus 2. Sine can never be smaller than minus 1 or bigger than 1. If you think of a parent sine graph, the highest it ever goes is 1 and the lowest is minus 1. And so when you get an answer like this, you can try go shift sine minus 2, but it will probably say math error or no solution or something. And so that's a good thing. It makes our lives much easier. And so we pour all our focus into this little guy. We do my 2 normal steps for general solution. Step 1, sine is positive. And so step 1, I tick the quadrants where sine is positive, which is the first and the second, because that's where all things are positive. This is where sine is positive. And then step 2, we always want to get a reference angle, and we'll go shift sine half, and that will give us our answer of 60. And so now that we know the reference angle, sorry, 30. Now that we know the reference angle, we can lay out these 2 quadrants. And so what you'd have is, if I want to get in the first quadrant, it's just going to be, the first quadrant will just be x equals 30 plus k 360. And that's the end of it. And to get into the second quadrant, over here, it would just be x is 180 minus the reference angle plus k 360, and that will give you an answer of 150 plus k 360. For an extra mark with general solution, you always want to, somewhere in the question, just say k is an element of the integer, which I'll explain in a sec. And so here are your general solutions. Why did I choose k 360? That's the period of sine. So if it was a tan graph at this stage here, then I would have said k 180. And then the last question, which can feel like it comes a little bit left field, but they're trying to see if you can see the connection. Hence, determine the 2 values of y between 144 and 216, which are quite weird numbers, but don't stress about that, are solutions of 2 cos 5y equals 3 tan 5y. And so the main trick they're just trying to see is, can you see that it's the same question as the beginning one, but x's have just pretty much become 5y's. So x's have just become 5y's. And so if I want the specific solutions, so like normally would be solving for x, I go from my general solution, which I'm going to rewrite for you, but instead of writing an x here in your general solution, I'm just going to replace it with 5y. And so it will start 5y equals 30 plus k360, or 5y equals 150 plus k360. Okay, so once you've seen the connection, that it's just the same question with the x's being 5y, then we can divide everything by 5 to get your new general solution. And we can divide everything by 5 here to get our new general solution. And to get the specific solution somewhere between here, all you're doing is you're just saying, anchor on this number. Is this number 6? Is that somewhere between the range that they're looking for in this case? And no, it's way too small. And so k is an element of the integer. Some teachers will sub in 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, and see what they get and if they can get a number in between here. For me, I find it's much easier just to literally go on your calculator and go 6 plus 72, and that's too small, it's 78, plus another 72. That gave me an answer of 150, which is looking good. So 150 is looking good. I'm going to add another 72 to that, and I get 222. I'm just too big, so that's the end of this general solution's usefulness to me. And then I'm going to go to this general solution, say 30. As I see the number, is it between there? No. So 30, if I add 72, that's 102. It's a bit small. If I add another 72, I get 174, which is good. If I add another 72, I get 246, which is just outside here. And so these are my only two legit answers. And so if you find that helpful, just to anchor on the general solution number and keep adding or minusing the number with k until you've gone outside of the domain or range, then go with that method of doing it. If you found this useful, please like this video, subscribe to our channel, and share this with your friends. Thanks.